Hey guys, Absolute 5 here. So let's get right into it. So today let's talk about something that has another derivative that is necessary. That's probably it's very crucial to know. So this is very important to know how to do this derivative, and that's using the product rule. Now, the product rule, you would think that you would take a derivative. One might guess you might take a derivative but the two functions, it's the derivative of the product should be equal to the product of the derivatives. I believe that's correct. I'm not saying it right, but what I'm trying to say is if you take a product of two functions, right, and you differentiate them, one would assume you could do this, that you can take the derivative of the two products. But no, that's not the case. You cannot do that at all. Why? Well, let's give a counterexample. If I let f of x equal x, and I say g of x is x squared, right? So let's plug that in to show that this is not true. Well, show that this is not true. So if I multiplied f of g of x, well, f times, well, this is why you can't do that, because then people might think you're doing a composition. F times g of x, you'd get what? That will be x to the third, right? And then you have to take the derivative of this. So if I differentiate this, I get 3x squared. Now I have to show that the two derivatives has to be equal to this. So what's the derivative of x? It's just simply 1 times the derivative of x squared, which is 2x, but we can clearly see there's a huge contradiction of 3x squared 3x squared is not equal to 2x. So that's why this idea, one would have loved this to be very convenient, but Leibniz thought about this as well, but he made modifications to this, and thank goodness he did, because he helped us create the product rule. This product rule is very different, so we're at the definition. It's very different. It's far from what this could have been, but that's just how life works. Sometimes you gotta reach deep, get something different. All right. So for the product rule, the definition is if f and g are both differentiable, then d over dx of f of x, g of x, where you have two functions that are being multiplied, it's going to be f of x times the derivative of g of x plus g of x times the derivative of f of x. So essentially what you're doing is you're multiplying the product of the sums and the sums of the products, if you want to think of it that way. Because I think it might be better visually if I wrote it on the second line, so you guys can see that actually real quick. F of x, d dx, g of x, g of x, d dx, f of x. So you see how it looks more neater this way? You see you're able to see that, well, not that neat, but you see f stays the same, you multiply by the derivative, plus you take g of x, which you leave alone, but you multiply by the derivative of f. So we're going to leave that formula, we'll leave it on top somewhere with the example so you guys can visually understand what's going on with the nice example. So d dx is, right of the product So our example is going to be y is equal to, when you sign, it's going to be x squared sine of x. There we go. So we have two functions that are being multiplied by each other. So let's label them. Sine will be g of x, and x squared will be f of x. So by literally plugging in the values here, which is exactly what we have here, we're going to apply the product rule. So y prime, the derivative of this, so it's f of x, which is x squared, times the derivative of g of x, which is sine, so the derivative of sine is cosine x, plus g of x, which is sine x, times the derivative of x squared, which is going to be 2x. Now, most people will try to assume that, there's an x here, so I can multiply these two, I get 2x squared. No. This x is a part of sine of x, so you can't do that. So all you can do is move this whole function to the front of, just like we have it here, you can move it to the front of sine. So this would be x squared cosine x times plus 2x sine of x. And that's your y prime. So that's how you apply the product rule, guys. It's simply, you take two functions, and the thing is they have to be kind of like glued together almost. And when you differentiate each one, it expands out. And the thing is, you have to be very careful when we're doing polynomials, because there are times where you have two polynomials, they're glued together, and then you have to expand it out via product rule. We'll get to that later on. So that's all we have for you today for today's lesson. So be sure to like, share, and subscribe to this channel. If you have any question, guys, I'm always here. Be sure to hit me up or down in the comments below. And always remember that it's been Absolute 5. I'm Roger Palomino. And that, what's my line? No, I know what my line is. Before I say my line is, be sure, if you like the content I'm providing, be sure to hit that bell button next to the subscribe button. And never forget, math is infinite because there are infinitely many possibilities.